Our next tool that uses waves to transmit information is a laser beam. Regular, simple laser pointer. We're going to use this to transmit music. So to do that, we want to look at how the laser beam works. Inside of this, there are two AAA batteries. The batteries put out a constant 3 volts. Two 1.5 volt batteries in series gives me 3 volts. And that gives me a very nice steady voltage. And when I push the button and put it on the LED laser, that gives a constant intensity of light. I have a constant watts of light coming out of the laser beam. But an MP3 player or a radio is putting out a variable voltage centered around 0. So the voltage is going positive and negative to create the sound wave. The more positive and the more negative it goes, the louder it is. The closer together the peaks are, the higher the frequency, the further apart, the lower the frequency. So this is sort of the signature of the music that's being played, but it's averaging 0 volts. It's all in the plus and minus and in the spacing. But if we take these two and we wire them together in series, we put the two batteries in series, and we put the MP3 player in parallel to the batteries, now what we're getting to the LED light is an average 3 volts plus or minus the music. So it's what we call a modulated voltage. This is a constant voltage. This is a modulated voltage. We add them together, we get a modulated voltage around 3 volts. So we take that and we shine the light, and what we get is the intensity or the brightness of the light or the power of the light in watts is now going to have a constant plus or minus a variation. The light will actually be flickering slightly. We can't see it, but it is flickering in intensity, therefore flickering in power relative to what the music is doing. So all we need to do is take that and point it at something that converts light energy into electricity, like a solar panel, and we shine our modulated laser on a solar panel, and now the solar panel, instead of giving out a constant voltage, it gives out a modulated voltage. And that modulated voltage is put into an amplifier, and it plays the sound that is the modulated part of things. Take a constant, add the music to it, transmit it as power, convert the power back to voltage, and play it as music. So here's our setup over here. We have a high-tech piece of 1980s boombox that has been hacked up and rewired, but coming out of it we have speaker wires, and the speaker wires come over and are connected to a audio jack, which I have wired into my laser pointer, and then I have a small solar cell that is wired up into a small amplifier. So we turn the amp on, we turned the radio on, we take the laser pointer, shine the laser beam on the panel, and listen to the radio. And you can see the music stops as soon as we get off from the solar panel. This also works, if I can get the camera to stand up on its own, if we take and we put the laser signal through a fiber optic. So now we're putting the laser through a fiber optic, bending it 90 degrees, and it still works. So that's one more example of how different waves can be used to transfer energy, and different tools can take that energy and pull it out of the carrier wave.